Dear students, in this lesson, we will learn about the basis, assumptions and within and between group variances of one-way ANOVA. After completing this module, the students will be able to understand the need for one-way ANOVA test. They will be able to understand the within group and between group variances. They will be able to understand the assumption behind one-way ANOVA. They can differentiate between fixed effect and random effect model. Let us begin with the basics of one-way ANOVA. We will discuss the need for ANOVA, case scenario for ANOVA, different perspectives of analyzing more than two groups, Bourne-Ferrigno correction and one-way ANOVA. To begin with, comparative studies are inevitable in psychology or behavioral sciences, especially when there is any intervention or new devices to be tested or compared with the existing ones. Often, the comparison items may be quite more, for example, 3 items, 4 items or so on. If we have more items to be compared, in order to bring out the benefits of the intervention, one needs a proper and robust tool. Consider a case scenario where a researcher wishes to compare 3 different methods of psychotherapy in terms of working ability of the subjects. He wishes to compare the 3 different methods. One is long-term psychodynamic psychotherapy, abbreviated as LPP, short-term psychodynamic psychotherapy, abbreviated as SPP, and solution-focused therapy, SFT. Consider a second scenario where a researcher wishes to compare the CRP levels among the 3 groups of subjects. For example, treatment-resistant depression, subject with non-TRD and control subjects, for the purpose of identifying the diagnostic value of CRP among the elderly patients with major depressive disorder, abbreviated as MDD. So, for the above scenarios, it is possible to use multiple t-tests for comparing 3 groups by comparing all possible groups of means, that is, all pairwise means we want to compare. But how? Let us go back to our kindergarten stage. Suppose we wish to compare the energy levels of 3 fruits, say strawberry, apple and oranges. Actually, we want to compare the energy level provided by these 3 fruits. How we can use multiple t-tests to answer this question? If you have decided to use a multiple t-test to compare these 3 fruits, we will compare strawberry with apple, and then strawberry with orange, and then apple with oranges. Doing so is acceptable. For several reasons, it is not acceptable. The first reason is doing multiple testing increases alpha error. Recall what is an alpha error. It is a probability of concluding there is a difference when there is no difference in reality. Meaning that for any experiment, if we fix alpha, that is your alpha error, by 5%, that is 0.05, we actually conclude that in 5 out of 100 samples, there is a difference despite the fact that there is no difference. Through multiple testing, we increase the alpha error. But how does alpha error increase? When we are comparing k different hypothesis tests, we actually increase the alpha error by the quantity 1 minus alpha raised to the power k percentage. In the fruit example, we have 3 fruits to be compared, and if we have fixed our alpha level as 0.05, then this quantity will give us 14%. So, it means we are increasing the alpha error by 14%. The logic behind this quantification is based on the probability. For each test, we are actually computing the probability of at least one type-on error. That is, what is the probability of making at least one type-on error? How we can evaluate this probability? That is, by 1 minus probability of committing no type-on error. What is probability of committing no type-on error? It is 1 minus alpha, and this experiment has been run for k times, so we are raising to the power k. So, we got the quantity 1 minus alpha raised to the power k. Now, if we are performing multiple testing, our alpha error keep increasing, but how to control this inflation? This inflation of alpha error can be reduced or controlled by a correction called as Bonferroni correction, which is given by Olive Jean Dunn. What is Bonferroni correction? Suppose you are doing multiple t-tests and you have fixed your alpha as alpha and the number of hypothesis tests you have is k, then you have to divide your alpha by the number of tests you are performing. So, the second reason is when we perform k multiple tests, we have k chunks of information and there is no comparison as a whole. For all this reason, doing multiple t-test is not advisable. So, what is the alternative is the one-way analysis of variance. In 1920, Sir Ronald Alimer Fisher have developed a technique called one-way analysis of variance. What is one-way analysis of variance? One-way analysis of variance, often abbreviated as ANOVA, tries to find a relationship between a continuous variable, often called as dependent variable, and the levels of a single categorical variable, often called as an independent variable. It is used to compare the means of k independent groups. For example, let us take the first case scenario where our outcome variable is working ability score of the subjects suffering from MDD. So, here the continuous variable is the working ability score, which is denoted by y quite often in the statistics books, and we have a second variable called group. This group variable is a categorical in nature, which is often you find as capital X, which is also called as factors, and these variable has 3 levels. So, you have first level, second level and 3 level. Just think about in our case scenario, we have introduced this as LPP, SPP and FST. So, we are trying to establish a relationship between the working ability score and the groups. When we establish a relationship between a continuous variable and a categorical variable, whenever we are testing, we will end up with statistical significance. If the statistical significance is there, then we can able to say the working ability score and the therapy is related. So, this can be done through ANOVA technique. So, one-way ANOVA is a parametric F test. It was devised by Sir Ronald Alimer Fisher. It is an extension of t-test for 2 independent means. Before diving into the concepts of one-way ANOVA, let us brush up the descriptive statistics. The first one is variance of the measurement, which is defined as the sum of squares of deviation of observation from the mean divided by a quantity called as n-1, which is called the degrees of freedom. The sum of deviations taken about the mean is always 0. This we will use for derivation of the sum of squares. Coming back to the variance, we have 2 quantity. The numerator quantity is the sum of squares and the denominator quantity is n-1, which is the degrees of freedom for variance, and it is also the degrees of freedom for standard deviation. In this video, we have learned about what is analysis of variance, few case scenarios relevant to one-way analysis of variance, and different perspectives of analyzing k independent groups or k independent means, and then we have described the basic statistics for further discussion. We will continue in the next video. Thank you.